Let's take a look in this video at a one-sample hypothesis test for proportions when we're looking at a left-tailed test. In this example, we're looking at the recent default rates on student loans. It's currently at 5.2%. In a recent random sample of 300 loans at private universities, there were 9 defaults. We want to see if the sample shows sufficient evidence that the private university loan default rate is below the rate for all universities. So we're going to use a left-tailed test and an alpha value of 0.01. Since we're doing a left-tailed test for proportions, we're going to set up our null hypothesis is that the pi is greater than or equal to pi naught, and our alternative hypothesis would be that pi is less than pi naught. Given the information that we have so far, our alpha value is 0.01, pi naught is 5.2% or 0.052. Our value for n is 300. Our value for x was 9. We had 9 out of 300, so we'll calculate our value for p as b21, our x value, divided by our sample size from b20, or 300. So now that we have our value for p of 0.03, we can calculate our values for our t-table. For our t-table, we're going to use the our norms inverse function, and we're going to use b18, which was our alpha value. So our value for our t-table is negative 2.326. We're going to compare that to our t calculation value. For our value here, we're going to take p from cell B22 minus B19, our pi naught, divided by the square root of pi naught times 1 minus pi naught, divided by our sample size of n. We get a value of negative 1.716. So our value here would be negative 2.326, and then our t calculation would fall to the right of it in negative 1.716, so we would fail to reject the null hypothesis. We can set that up with our logic here as well, that if B24, our t calculation, is less than B23, our t-table, we would reject our null hypothesis. Otherwise, we would fail to reject our null hypothesis. So we have the correct conclusion of failing to reject our null hypothesis. We can also calculate our p-value. Our p-value is going to be norm.s.dist for our z-value from cell B24, and then for cumulative, we'll use a 1. So our p-value is 0.0431. This value is larger than our alpha value. However, we can make our conclusion with over 95% confidence. Since we had the assumption in this problem of normality, we can also check to see if that assumption was justified. So here, we're going to start by calculating n times pi naught, and that gives us a value of 15.6. So our assumption is justified if this value is greater than 10. We also want to check the value of n times 1 minus pi naught. For this calculation, we have 284.4, which is also greater than 10. So therefore, our assumption of normality is justified. We can set that up with our logic here as well, that if both of those calculations are greater than 10, then our normality is justified. However, if one of those values is not greater than 10, the normality assumption would not be justified. So luckily in this problem, in this example, normality is justified.